Hey everyone, welcome to my channel. If you like tech and helpful tips, don't forget to subscribe. Let's get started.
Removing a weld, whether due to a mistake, a necessary repair, or a design modification, requires a methodical approach and, most importantly, a steadfast commitment to safety. Before you even think about touching a tool, ensure you have the proper personal protective equipment, PPE, on hand. Heavy-duty welding gloves, ANSI-approved safety glasses or a face shield, hearing protection, a respirator to protect against fumes and dust, and appropriate fire-resistant clothing. Good ventilation is non-negotiable, and having a fire extinguisher readily accessible is paramount. There are several effective methods for weld removal, each with its own advantages and ideal applications. One of the most common and accessible methods is grinding. An angle grinder, equipped with a grinding disc or a flap disc, allows for precise material removal. Start by using a coarser grinding disc to remove the bulk of the weld material, working slowly and deliberately to avoid digging into the base metal. The goal is to gradually reduce the weld bead until it's flush with the surrounding material. For a smoother finish, switch to a flap disc with a finer grit. Always keep the grinder moving to prevent localized overheating, which can warp the material. This method is excellent for smaller welds or when high precision is required, but it can be time-consuming and generate a significant amount of dust and heat. For larger or more stubborn welds, thermal cutting processes are often more efficient. Plasma cutting, for instance, uses an electrically generated jet of hot plasma to cut through conductive metals quickly and cleanly. It's much faster than grinding for bulk removal and can be quite precise with a steady hand. However, it requires specialized equipment, an air compressor, and generates considerable fumes, necessitating excellent ventilation. Another thermal option is oxy-acetylene cutting, which uses a torch to heat the metal to its ignition temperature and then uses a stream of oxygen to blow the molten metal away. While effective for thick steel, it's generally less precise than plasma cutting and creates a larger heat-affected zone. For very large, heavy welds, carbon arc gouging is an incredibly powerful method. This process uses a special torch with a carbon electrode to create an electric arc that melts the metal, while a stream of compressed air simultaneously blows the molten material away. It's exceptionally fast and can remove a significant amount of weld material quickly, but it's also very noisy, messy, and produces a lot of fumes and spatter. Less common for full weld removal but useful for specific situations is drilling out spot welds or using a chipping hammer for brittle welds or heavy slag. When choosing your method, consider the type and thickness of the material, the size and location of the weld, the tools you have available, and the desired finish. After the weld material is removed, inspect the area thoroughly for any remaining imperfections or damage to the base metal. You might need to do some final grinding or sanding to achieve a smooth, clean surface. Remember, patience and safety are your best tools in any weld removal process. Thank you for watching, and please subscribe for more welding tips and tutorials.